Hi guys, quick review today of the classification scheme of the periodic table, the types of elements, those groups and families, and then the major categories. And then we want to move into, again, taking a closer look at that valence energy level and learn a little bit more about the octet rule, because the valence energy level is something we want to be keeping a close eye on because it determines how elements behave. So again, looking at a periodic table, you've got that stair-step line on the far right. Those that lie right on the stair-step line, those are known as metalloids. They're shaded in sort of a purplish color here. Far right-hand side, the non-metals, and then the bulk of the periodic table, shown in gray here, the metals. Metals are supremely important to us. You can see that they constitute about 2/3 of all the known elements and almost a quarter of the mass of our planet. They are really useful to us. They have properties that make them useful. First of all, they are conductors, both of heat and electricity. They can be shaped into various utilitarian shapes, and that's known as malleability. Pulled into wires, that's known as ductility. They're very, very strong and durable, and so metals are really very important to our day-to-day lives. Some of the things that you might notice visibly about metals is that they are lustrous. They have that little shine to them. Nonmetals, on the other hand, over on that far right-hand side, plus hydrogen. Hydrogen is that lone nonmetal that's on the left-hand side, so pulling it over to the right just for illustrative purposes here. Nonmetals are mostly gases at room temperature. There are a few that are solids at room temperature, and even one that's sort of semi-liquid at room temperature. Um, they are not good conductors. They are not malleable or ductile. They are rather brittle at room temperature, or they're gaseous. And also they have low boiling points and low melting points. Okay, so the metalloids, I want to talk just a little bit about those. Um, they are really a unique group of elements because they have sort of characteristics of both metals and nonmetals. They are not as brittle as nonmetals, and in terms of conductivity, they are what we would call semiconductors. Semiconductors are probably something you've heard of before because they form the basis for the technology field. We would not have cell phones, computers, internet, anything like that without semiconductors. And so that's a very unique thing about the metalloids. Last chapter, we took a look at dot diagrams, and this pattern should be familiar to you now. The numbers that you see at the top are those A group numbers. With one exception over here, we're not showing helium, and the reason we're not showing helium is simply because it gets a little confusing because helium only has 2 electrons, but keep in mind that's still a stable configuration because it only has 1 energy level. And 2 electrons in the first energy level is a filled first energy level. So it's important to know that that's stable as well. But you can see the trend in the A groups, 1, 2, 3, 4, 5, 6, 7, and 8. And what's important about that for us to make sure that we know that and we can see that everything within a family has the exact same valence energy level. They all have the same number of dots. That means they all have the same number of electrons. Well, that should tell you something. It means they are going to behave similarly because what elements do is they interact with other elements in order to achieve a more stable outer energy level. They want to be more like a noble gas. So they're either going to lose electrons or they're going to gain electrons in order to be more like a noble gas. There are some categories here that are important to recognize, and we're not going to spend a lot of time going into these special names, but over here on the far left, this gold group, group 1A, those are also known as the alkali metals, and the alkali metals are the most active metals on the periodic table. Right next door to them, group 2A, would be the alkaline earth metals. Also very active, just not quite as active as these, but still really, really active. And when I say active, that means they'll react with other things. Far right-hand side, we've got the halogens. Something important to think about with the halogens is that they're really useful in disinfecting things. You've heard of chlorine before and iodine, probably in, like we know Clorox wipes are used for sanitizing surface. Well, Clorox is a type of bleach and it's a chlorine bleach. Iodine is something that you probably have seen used like in the medical field, like if before they do stitches or something, they'll put iodine across a field of skin in order to sterilize it. The noble gases over here, again, non-reactive, and they're really useful in that non-reactive. They're used for certain things because they will not react with other things. These others are usually identified simply by their A group number or the element at the top of each of these families going down. Like this would be the oxygen family. This is the nitrogen family, the carbon family, and so on. So the octet rule, you guys, octet, OCT, of course, means 8. And the octet rule refers to the tendency of atoms to prefer to have 8 electrons in the valence energy level. Now, the exception is for smaller atoms that want to be more like helium and have 2, because remember, if it's small, it only has 1 outer energy level or perhaps 2. It's going to actually just go towards the noble gas helium configuration in its interaction. But the rest of these, neon 2, 4, 6, 8, argon 2, 4, 6, 8, something like fluorine, which has 7, will try to get 8, so it's more like neon. Something like chlorine, which also has 7, will try to be more like argon, and so on. And that's what the octet rule is all about. All right, have a great day.